Again, here with 6, all we want to do is just practice using our quadratic formula. And like looking at this main equation starting out, I see first of all it's not set equal to 0, and I see that my x squared term, for one thing, I have a choice. I can either move that 4x to the right, or I can move the terms on the right to the left. I'm actually going to choose to move the terms on the right to the left because it seems easier for me, especially in case I was factoring, to make my front term, my largest term, the x squared term, make it always positive. So what I'm going to do is start chunking those two over and then organizing them that way. So a negative 2x squared is going to become a positive 2x squared. We still have that positive 4x because it's already on that left side, and then a positive 3 going from the right to the left will make it a negative 3, and then that equals 0. Okay, so we're all set up, ready to start doing the quadratics. So a is equal to the coefficient on the x squared, b is the coefficient on the x term, and then c is just always the constant. It's always the term that doesn't have a variable with it. And if I just wanted to kind of say, just real quick, if I wanted to play what ifs, what if it was, 2x squared minus 3x equals 0? So in that case, what a would be 2, b would be negative 3, and then c, since there is no constant term, would be 0. So if there's a missing term, just put a 0 in for it. So that's just kind of one of those what ifs off to the side. Okay, if we want to use the quadratic formula, let me just put that back up in there. And guys, you're going to have this memorized. So if you don't know this already, definitely take the time. And one of the easiest ways to memorize a formula if you don't know it is to keep writing it out every single time. So as you go throughout all these examples and you're sitting there and you're like, I don't know this, every time you get to the problem where it says, hey, use your quadratic formula to solve this, just do what I did. Write it out every single time. Okay, so x is equal to negative b, so negative 4 plus or minus the square root of b squared. So 4 squared minus 4 times a times c all over 2 times a. Okay, so x is equal to negative 4 plus or minus the square root of 16. Looks like we have a negative times a positive times a negative, so it's going to come out positive. 4 times 2 is 8, and 8 times 3 is 24, all over 8. I'm sorry, 2 times 2 is definitely not 8, it's 4. Okay, x is equal to negative 4 plus or minus 16 plus 24. Well, it looks like, again, we're looking, square root of 40 is popular here in my notes today. And we're going to break that up to 4 times 10. Remember, because 2 times 20 won't help us at all. We got to use it as a product of something we know we can take a square root of. So the square root of 4 comes out, it's 2. Square root of 10 is going to stay inside, all over 4. And just like we did with the last problem, when we want to see, hey, can I clean this up at all? We're going just to the everything on the outside that has nothing to do with that radical. So that's divisible by 2, that's divisible by 2, and that's divisible by 2. So finishing this up, we'll get x to be negative 2 plus or minus, if I want to put a 1, I can, or if not, just square root of 10 all over 2. And there are my answers. One time being negative 2 plus the square root of 10 over 2, and the other one being negative 2 minus the square root of 10 all divided by 2. All right, let's try to get the same concept. Let's go to example number 7. Here in example 7, first of all, just looking at the problem, it doesn't say, okay, for sure we have to use the quadratic formula or we have to factor. So we got options here. I might go back to factoring. We'll see. And next thing I notice is the fact that, okay, we have all my terms on one side and it all sets up to equal to 0, so that's great. But the thing of going on that left, we have higher powers. Instead of x squares or y squareds and then y to the first, we start with a 4th power. Well, just let you know, not much is going to change. It's just when we go, I'm going to try factoring. When I go to factor, then I have options here. Because remember, the fronts always have to multiply to y to the 4th. So they could be technically y cubed and y to the first, right? Or it could be a y squared and a y squared. Because y cubed and y to the first, same base, you add your exponents and we get a 4. Or here, y squared and y squared, add 2 and 2 and you get 4. So which pair do I go with? How do I know? Well, that's when you have to go to that center term. Look at that exponent on your center term. You see how it says y squared? That's going to be our guide. So we definitely don't want this first one up here at all. It's not going to help us at all because that middle term has a y squared with it. That right there tells us exactly what to do. We're going to go with the y squares. Okay. And now, the original problem, it has a leading coefficient of 1 because it's a 1y to the fourth. So I get to do the factors of 6, positive 6, that add up to negative 5. That's not too bad. Negative 3 and negative 2. Okay. And let's just take 2 seconds to double check. Y squared times y squared is y to the fourth. Outsides would give us a negative 2y squared. Insides would give us a negative 3y squared, so that's definitely negative 5. And negative 3 and negative 2 is give us a positive 6. All right, got 2 parentheses that are factored, so we can set each one of these factors equal to 0. And then let's move our constants over, so we get y squared is equal to 3 and y squared is equal to 2. And like before, up above in our last lesson, we talked about how to get rid of a square root in an equation we squared. Well, how do you get rid of a square? Is you take a square root. But here's the one thing you got to remember. I'm going to put a wonderful star with this. Is anytime you do take the square root of both sides, you always have to do this thing called plus or minus. So the square root of y squared is y, but over here it has to be plus or minus the square root of 3. Same thing with this other one, plus or minus the square root of 2. But let's just go with something basic. Here, I'm going to box these up real quick. We're going to call this done, but why this whole plus or minus? So let's go, what if I gave you something simple, like y squared was equal to 4? Let's read into this. This says, what do you have to square to get 4? Well, obviously 2 times 2, so 2 squared is 4. But isn't also negative 2? What's negative 2 times negative 2? It's a positive 4. So we need the plus or minus to give us our plus and our minus answer. Okay. So whenever you take this, if you find yourself at the point of solving a problem, and you're at the point where you need to take the square root of both sides to get rid of a square power, then always, always, always make sure you put a plus or minus in front of there. And you'll get your problem right every single time. And look at this. How many answers are we getting? We have y to be a positive square root of 3 and a negative square root of 3. So there's 2 answers coming there. A positive square root of 2 and a negative square root of 2. There's 2 answers. There's a total of 4 answers. Go back to the original problem. That highest exponent was a 4, telling you that you're going to get at most 4 solutions. And we got all 4 of them. All right. Okay, well, let's take this on and let's go on to another problem. Example number 8. In example 8, we really don't have a quadratic anymore because we've got x and 2 and it's equal to 0 and all, but here's the difference. This is actually called a rational function, mainly because you have a variable in the denominator. That's the key, is with all of this is the unique fact that we have a variable in the denominator. Okay, so we have a set of rules or set of steps that we've got to follow anytime. When we have a quadratic, we just set it equal to 0, and then we either factor or we use the quadratic formula. So now it's figuring out what do we do whenever we have a variable in the denominator of a fraction. And if you took even 2 seconds to pause the video and flip back from your notes from 1.6 and 1.7, you will realize in some of those examples that had fractions, anytime we had a fraction, they were just like with 3's in the bottoms or 4's in the bottoms, just regular numbers. So this is really the first time we've ever seen a variable in the denominator. So how are we going to go about handling this? Well, I do exactly what I've done in all we did in the first part of this, the part 1 of the lesson back in 1.6 and 1.7. Anytime you see a denominator, let's clear it out. And how we're going to clear it out is we're going to multiply by whatever is sitting down there, or the LCD. Okay? So in this case, what we're going to do, our LCD is just, because there's only one denominator, it's going to be 2x minus 1. Now let's go up there though and let's identify how many terms. So how many times am I going to have to multiply 2x minus 1? Well, I have an x. I got a plus sign to stop it, so that separates the term. I've got a 2, a minus sign, so another term, and then this fraction, and then equals 0. So I'm going to be multiplying 2x minus 1 to 3 things on the left and just the 0 on the right. So let's go show how this is going to work. So I have 2x minus 1 times the first term, which is x, plus 2x minus 1 times the second term, 2, minus 2x minus 1 times the fraction, and then 2x minus 1 times 0. So I just went through and I multiplied my LCD, my denominator, in this case, by every single thing up there. All right, well, let's go multiply all this out. X times 2x minus 1 will give me 2x squared minus x. 2 times that will give me 4x minus 2. Now right here, the 2x minus 1 is going to cancel with the 2x minus 1, giving me just 3. And that's great, because that's the whole reason why I did this, was just try to get rid of that fraction. And then over the right, 0 times anything takes all that away, and it still equals 0. All right, so if we analyze what we have left, we basically have a quadratic, don't we? Because we have an x squared term, and we have all these other terms on the left. It's equal to 0, so it's really set up for us to solve. Let's group some stuff here on this left. It says 2x squared. Let's see, a negative x and a positive 4x will be a positive 3x. Let's see, minus 2 and minus 3, minus 5 equals 0. Again, I tend to favor factoring. I've got more practice with that. It's something that was embedded in my brain ever since I was in middle school. So it's like I just naturally gravitate towards factoring as opposed to using quadratic. But if you choose to use the quadratic, especially if you're not familiar with it, I would say I'm going to factor here, but you use the quadratic. Pause the video, you get an answer using the quadratic, and let's compare answers. But you should be getting the exact same answer either way. Okay, so I'm going to factor 2x and x. And if you're not really a great factor, you need help with more of these skills, obviously pause your video. Try to factor this on your own. Don't just watch me do it every single time. You need to get the practice of this for sure. Okay, we want to place the factors of 5 in the back here. So we need to go with 5 or 1. I'm going to put a 5 right there and a 1 right there, and we need to add up to a positive 3. So I need my 5 to be positive and then my 1 to be negative. And just double checking the outsides will give me a negative 2x. The insides will give me a positive 5x. So that's 3x and then minus 5. Okay, so 2x plus 5 equals 0. X minus 1 equals 0. So move that 5 over, and 2x is now negative 5. Or x is negative 5 halves. Moving that 1 over, and x is equal to 1. So here are my two potential solutions. Now, just like what we did before up in sections 1.6 and 1.7, is anytime you had a radical in your problem, you had to check your answer. Because with a square root sign, we can never take square roots of negative numbers. Kind of the same rule applies here. Anytime you have a fraction in your equation, remember one thing you can never do is you can never divide by 0. So since they're, like over here on this note right here, is since there's a variable in the bottom, you must check your answer, because if you want to write this, because you can't divide by 0 ever. That's the point. So what we're going to do, just real quick, we're going to check. So let's check with x equals 1. I'm only going to go to the term that's a fraction. So 3 over 2 times 1 minus 1. And all I'm wanting to do is just making sure that when I plug this 1 in, that I'm not dividing by 0. So this will be 3 over 2 minus 1, which gives me a 3 over 1. So that checks out, because I'm not dividing by 0, I'm dividing by 1. Okay, let's check out the negative 5 halves. So I really don't have to plug it in the whole thing. It's going to be just a quick check. Just go to the term that has the fraction in it, and make sure that by the time you plug it in, that denominator is going to give you something other than 0. Okay, so right there, 2 times negative 5 halves, the 2's will cancel, so I'll just get negative 5 minus 1, which gives you 3 over negative 6, and that right there I can go ahead and check off, because that's definitely not a 0. So both of these answers work. They're going to both work for the whole problem. Okay, all right, well, let's step this up. Let's go to example 9 and make this just a little bit harder.